video, we are going to be looking at differentiation from first principles. Now let's consider the equation on the screen. We are given that y is equal to 2x to the power of 3 minus 4x squared plus x, and we are asked to find the y dx from first principle. Now when solving this, keep in mind you have to increase y by a change in y, and if you do that, that means you're also going to increase x by a change in x. So you have y plus change in y. This is going to be equal to, I have 2 as a constant to factor it out. Open your bracket. In place of x, we now add change in x to it. So we have x plus change in x. And since x is to the power of 3, it means you're also going to increase this to the power of 3. So that becomes x plus change in x to the power of 3. Now I have negative 4 here. Now in place of x squared, also increase x by change in x. I'm going to have x plus change in x, then all squared. Again, I have plus x. So in place of x, simply you have x plus change in x. Alright, now what you need to do next is simply what? Expand the brackets, right? You have to look for the value of expanded value of x plus change in x to the power of 3 and that of x plus change in x to the power of 2. So to easily solve this, we are going to be using the binomial expansion. So let's do a quick a rough sketch of the binomial expansion. So we're using the third power, right? So for third power, remember it is simply 1 3 3 1 for third power. So which means if you want to expand x plus change in x to the power of 3, this is actually going to be equal to 1 times x. That gives us x to the power of 3. 1 times x to the power of 3 multiplies change in x to the power of 0, which remains x to the power of 3, plus then you will have 3 times x to the power of 2 multiplied by change in x, plus you also have 3 times x to the power of 1 multiplies change in x to the power of 2, plus then you will have change in x all to the power of 3. So this is the expanded value of x plus change in x to the power of 3 using the binomial or the Pascal's triangle. Whereas for square, it is simply what? 1 2 1 for the second power using Pascal's triangle. So which means to expand x plus change in x all squared, this is going to be equal to, so it will be 1 times x squared times change in x to the power of 0, which remains x squared, plus 2 times x times change in x, okay, plus change in x all squared. So this becomes the expanded value of x plus change in x squared. So let's plug all these values into the equation above for y. So that means I'm going to have y plus change in y to be equal to, so we have 2 times, in place of x plus change in x to the power of 3, we are simply going to have what? We've already gotten the expanded value to be x to the power of 3, plus we have 3x squared change in x, 3x squared change in x, plus 3x change in x squared, plus change in x to the power of 3, close your bracket, minus, we have minus 4, open your bracket, in place of x plus change in x squared, we have x squared plus 2x change in x plus change in x all squared, then we have plus x plus change in x. Okay, so this means y plus y plus change in y is going to be equal to, so let's simply expand these brackets at this point. So using 2 to expand this bracket, I will have 2x to the power of 3 plus 2 times 6, 2 times 3 here gives me 6x squared change in x, plus 2 times 3 once more gives me 6x change in x squared, plus 2 times change in x cubed gives me 2 change in x cubed. Now using -4 to expand this other bracket, I'll have minus 4x to the power of 2 minus 4 times 2, that gives us minus 8x change in x, minus 4 change in x squared, plus x plus change in x. Now since I'm looking for dy all over the x, I will simply transfer y to this side, to the right hand side of the equation, leaving change in y at the left hand side. So I'm going to be having change in y to now be equal to, this is 2x to the power of 3 plus 6x squared change in x plus 6x change in x squared, change in x to the power of 3 plus 2 change 6x change in x squared plus 2 change in x to the power of 3 minus 4x squared minus 8x change in x minus 4 change in x squared plus x plus change in x minus y, not forgetting if a positive sign cross an equal to sign, it becomes negative. So if y crosses over, it becomes negative. But not forgetting that y itself, from the question, y is giving us 2x to the power of 3 minus 4x squared plus x. So which means we are going to be replacing y over here. This negative y will now be what? Standing for this value, so that everything will become in terms of x, right? So let's put in the value of y in this equation. So we're going to be having change in y. So we'll have change in y to be equal to, this is 2x to the power of 3 plus I have 6x squared change in x plus 6x change in x squared plus 2 change in x to the power of 3 minus 4x squared minus 8x change in x minus 4 change in x to the power of 3 plus x plus change in x minus, in place of y is actually 2x to the power of 3 minus 4x squared plus x, and you have this. Okay, so if you rewrite that equation, you're going to have that change in y is equal to, so this is 2x to the power of 3 plus 6x squared change in x plus 6x change in x squared plus 2 change in x to the power of 3 minus 4x to the power of 2 minus 8x change in x minus 4 change in x to the power of 3 to the power of 2, please, to the power of 2 plus x plus change in x. So let's expand this bracket now. It becomes minus 2x to the power of 3 minus times minus 4x squared, that becomes plus 4x squared, minus times plus x becomes negative x, and we have this. So let's observe that I have over here, I have 2x to the power of 3. Over here I have minus 2x to the power of 3. So obviously there are 2 cancels out. Similarly, I have minus 4x squared, and I have plus 4x squared here, so these two also cancels out. Then again I have plus x here, and I have minus x here, so that two also cancels out. So let's strike them. 2x cubed, 2x cubed cancels minus 2x cubed. Then I have minus 4x squared, that cancels plus 4x squared. Finally I have plus x here, this cancels minus x, right? So this means my change in y is now going to be equal to, so I have 6x squared change in x, so I have 6x squared change in x, plus I have 6x change in x squared, plus I have 2 change in x to the power of 3, minus I have 8x change in x, minus 4 change in x squared. Then I have plus change in x here, not forgetting, so you add that, so you have plus change in x. Okay, so let's evaluate this and see. Now at this point what you simply do is divide both sides by change in x, since we're looking for dy over dx, right? So we divide both sides by change in x, so that becomes change in y all over change in x. This is going to be equal to, so I'll divide everything here by change in x. So I have 6x squared change in x divides by change in x, plus 6x change in x squared divides change in x, plus I have 2 change in x to the power of 3 divides change in x, minus I have 8x change in x divides change in x, minus 4 change in x squared divides change in x, plus I have change in x divides change in x. So that means I'm going to be having change in y all over change in x to be equal to, so from here change in x cancels change in x. I have 6x squared, plus here I have change in x cancelling one of this change in x, so I am left with 6x change in x, plus I have change in x also striking one of this change in x. I have 2 change in x all squared, minus I have change in x here striking this change in x. I have 8x there, minus I have change in x here striking one of this change in x. I have 4 change in x, plus change in x goes into change in x, that simply gives me 1. Now at this point the limit at which change in x approaches 0, the concept change in y all over change in x automatically becomes dy all over the x. So this is simply saying that when you get to an equation in this form where I still have change in when I found change in y over change in x, and I still have change in x in between the equation or in between the given equation here, what do? Simply consider change in x to be 0, and then change in y over change in x automatically becomes the y all over the x. So that means wherever I see change in x in this whole expression now, I'll call the value to be what? 0. So if I do that, I'm going to now have that dy all over the x is equal to, so I have 6x squared plus, this is 6x change in x, so in place of change in x is 0, plus 2 change in x squared, in place of change in x, that is 0 all squared, minus 8x minus 2 change in x minus 4 change in x, and change in x is 0, plus 1. So this simply implies that dy all over the x is now going to be, I have 6x, okay, now 6x times 0, this is off 0, 2 times 0 also 0, so I have minus 6x squared minus 8x, again 4 times 0 is 0, so I'm left with plus 1, and this becomes the answer of that question from first principle. Now let's prove this using the power rule. Let's prove this answer using the power rule, right? So we have y to be equal to 2x to the power of 3 minus 4x squared plus x. Therefore, the y over the x is equal to, remember from the power rule, you use the power of the variable to multiply the variable, then you subtract 1 from the power. So I'll pull out 2 since 2 is a constant, and in this case is multiplying. Now the power of x there is 3. I will use 3 to multiply x to the power of 3. Then I will simply subtract 1 from the power. Minus, also pull out 4. The power of x attached to 4 there is squared. That's 2. So use 2 to multiply x squared. Then subtract 1 from the power. Now plus, this is x. And the power of x there is simply 1, right? X to the power of 1 remains x. So use 1 to multiply x. Then subtract 1 from the power. So I have 1 minus 1. So that means this is going to be equal to 2 times 3 here gives me 6. X to the power of 3 minus 1 is 2. You have this. Minus 4 times 2 here gives me 8. X 2 to the power of 1 is simply what? 1. So that means 8x. Okay, plus, now 1 times x. Now this is 1 times x to the power of what? 1 minus 1 is 0. And any variable to the power of 0 is 1. So this actually means 1 times 1. So this means that dy all over the x is equal to what? I have 6x squared minus 8x, and plus 1 times 1 is simply 1, which is the same result that we obtained above when we used the first principle to solve. Alright guys, so that's it on first principle of differentiation. Just in case you have any troubles with first principle, you can do well to slide into my DM on WhatsApp, or you can do that on the comment section, and I promise to respond to all your questions. In the next video, we are going to be looking at first principle differentiation of fractions. I'm sure you want to be a part of that video, so do well to like this video, comment nicely, share to your friends, and click the subscribe button and turn on your notification bell so you don't miss out on that video when it drops. I will see you in the next video. Thanks.